Alright, hello, welcome back everybody. This is problem number 20 and video number 20 from the AP Physics C Mechanics multiple choice test. Alright, here's the problem. A student throws a metal sphere which follows this path, as I've drawn in this diagram here. If air resistance is negligible, which of the following is a correct relationship between the magnitudes of the accelerations AK, AL, and AM at the points shown? So the acceleration of the metal sphere here, here, and here. It's asking us to compare these three accelerations. So in projectile motion, there are many ways to solve for acceleration. We have equations like V is equal to V naught plus AT. There's many of these. We can go delta x is equal to like x initial, or is it x initial plus delta x is equal to v naught x plus 1/2 at squared. There's a couple other ones, but for this equation we actually don't need to use any of these, so let's cross these off. This equation is simpler than you would think. So just looking at these options, they basically, one says all the accelerations are equal. B is saying the acceleration at K and L are equal, but those are both going to be greater than the acceleration at M. D is saying the acceleration at L and M are equal, but that those are going to be less than the acceleration at K. And E is saying that the acceleration is going to be greatest at K, second greatest at M, and least at L. However, the way that we should look at this problem is, again, the fact, let's talk about position, velocity, and acceleration. Velocity is the first derivative of position, acceleration is the second derivative of position, acceleration is the first derivative of velocity. So we know if it's thrown from this point here at like an initial velocity, that velocity is going to decrease as it gets higher. That's why the slope is getting less steep, because the velocity is decreasing. And then here we know that the velocity in the y direction is equal to 0. That's hard to read, I know it's far away. Let's see. There. You can see that a little bit. But that other, so yeah, we know that the y velocity is 0 at point L, but that's really all we know for the velocities, except that the velocity is going to be positive, decreasing, and then negative here. But acceleration, on the other hand, this derivative of velocity is going to be constant throughout, because the only acceleration here is the force of gravity again. This question is trying to trick you with all these answers, but it's really very simple. The acceleration here is gravity throughout the entire thing, which is 9.81, or for the purposes of the test, for simplifying your calculations, approximately 10. So in that case, A looks like a pretty good answer. Let's go through all of them. B, no, this L is not, the acceleration here is not going to be greater than here. It's going to stay constant. The acceleration at M is not going to be larger than L. Nope. The acceleration at K is not going to be larger than L. And this says they're all going to be different, which is false. So, A, let's select our correct answer. We know that the acceleration at all 3 points is going to be equal, because we know that the only acceleration, the only force acting on these, well, not the only force, but the acceleration is just going to be gravity. It's just going to be deaccelerating in the y direction at this rate. This is a G, not a 9, just so you know. Again, fairly simple projectile motion. Don't get caught up trying to use all these equations, because they don't give you any values to plug in. That's not the way to go with this. This is really just a conceptual problem. They want you to think about how to do this. So Thanks for watching. Let me know what you think of the video, and I'm going to move on to question number 21, so check back in. Thanks for watching.